Hello everyone, August 27th. It's 12 at noon. Let's go right into it. Longest common subsequence number 2. Given an array of strings, return the length of the longest common subsequence between them. If the longest I just read longest common. Longest uncommon subsequence. My God. Return the length of the longest uncommon subsequence between them. If the longest uncommon subsequence does not exist, return -1. An uncommon subsequence between an array of strings is a string that is a subsequence of one string but not the others. A subsequence is as that can be obtained after deleting any number of characters. For example, ABC is a subsequence of this because you can delete the underlined characters to get ABC. Other subsequence can be So the maximum of only 50 strings and 10 for each string. Longest uncommon between any array, right? So in this one, it's ABA or CDC, right? There's the 3 because they're all uncommon. Between an array of strings is a string that is subsequence of one string, but not the other. So what we're trying to find is the longest subsequence, right? That is uncommon. So a longest subsequence that an uncommon between an array of string is a string that is subsequence of one string. It's only one string. So it's a subsequence of just one string, but it's not a subsequence of all the other strings. So that is the target we want to find. And we cannot find one here because any subsequence of any string is the subsequence of another string. Okay. So the longest uncommon subsequence between an array, I mean, for one thing, if we have does that mean like the longest common subsequence is, no. Now the longest common subsequence between two, not really. Hold on. What are we trying to find? A subsequence of a string, right? And we have to test every single string. The subsequence of the first string, and then we're trying to say if does it exist in all the other strings as a subsequence. Huh. The longest uncommon subsequence. How do I know if a subsequence is uncommon in another string? How do we know that? We compare them. So let's say a subsequence, when we take it out, it is a string by itself, right? So the question is, if I've given you a string and I give you another string, how do I tell that the first string is not a subsequence of the second string? Well, how do I tell if the first string is a subsequence of the second string? I mean, we compare. Because if it is a subsequence, then let's say the first letter must appear somewhere in it, right? So if it appears somewhere in it, then we compare the second letter. If the second letter cannot be found, then we go back to the previous one, right? So Some cannot be found, we go back to the previous one, and then we keep looking. So in this case, we will how do I find it efficiently? Oh, we can use longest common subsequence, right? If a string is a subsequence of the next of another string, then the longest common subsequence will be the length of that. Will be the length of that. So if it's not, then the longest common subsequence will be shorter than the given string. So that's how we tell if it's a subsequence of another string. Okay, so that takes O(n) squared, but because the string length is smaller than 10, so that won't take too long. Okay, so we can identify that. That's fine. So what? I just we cannot grab all the subsequence of any string. I mean, the common subsequence. It has to be something to do with the common subsequence. Like if I say toString has 0 common subsequence, right? We have a 0 common subsequence. If that happens, that means the entire string is the longest uncommon subsequence. If toString has something in common, like say 1 in common, then the entire string will be, the entire string will be. So the only time, wait, what are we saying here? We have a list of strings, right? So we can go to the first string, compare with everybody else. And when we do the comparison, we find the longest common subsequence between them, all right? The longest common subsequence between them. And once I find the longest common subsequence, then all I need to do is, hold on one more second. And it didn't say all the words will be the same length, no. Okay, I'm going to read it again. The length of the longest uncommon subsequence between them. So we sort by length, right? We sort by length. I have a small question. Let's run a test case. See, let's say we have this, right? Will this answer be 1? Be 2 or be 3? I think it should be 2, right? Ooh, the answer is 3. The answer is 3. But what if I do this? What's the answer of this if I say it's 3? An uncommon subsequence between is a string that is a subsequence of one string, but not the others. Let's say ABA is a subsequence of ABA, but is not. How will this one go? That's 3. Oh, the reason that this is -1 is because of this. Which means if we go AAA and AA, that will return A3. Because AAA is not a subsequence of AA. Okay. Then we just pick the longest, right? The longest string will not be a subsequence of any smaller strings. All right? So we sort it based on size, reverse. So we go from the biggest size, and if the biggest size we can handle, right? If we have the biggest size and we identify the biggest size, hold on. So the biggest size, so we group them by size, right? So we have, from the largest size, we have like a smaller, like a dictionary with size, right? And then we have a bunch of strings of the same size, right? Strings of the same size. And we're trying to see if the string of the same size can be string of the same size if they can be uncommon to each other, and then that is the solution, right? If they are not uncommon to each other, string of the same size, and they're not uncommon to each other. What does that mean? String of the same size that are not uncommon, then they must be the same. Right? If I am a string of length 5, and then you are the string of length 5, and I say a string 5 is not an uncommon, so a string of 5, I am a subsequence of myself, and I am not an uncommon subsequence of you, which you are also 5. This cannot be, all right? Because like, as long as there is a slight difference, then I am not a subsequence of you. Exactly, like if we have a small difference, let's say we have a 5, right? And then you are a 5. Then I am a subsequence of you. But if you change just a little bit, then I am not a subsequence of you. So the answer will become 5. Yeah? So all we need to see is the string of the same size if there are any repeats. All right? Now, even if we have repeats, that's fine, right? If we have repeats, that's also fine. This will still be 5 because if I choose this as the subsequence, then it satisfies. So this shall be 5 as well. Yes, which means as long as there's one unique string, right, in the same size, one unique string, and that string will be the answer. And we can pile loading like all the other, we can pile in the 4 A's, right, 3 A's, 2 A's, does not matter. The answer will be 5. This one, the answer will be 5. Yes, right? So we check the string with the largest size, and we see if there is any unique. If there's no unique, if there's at least one unique, that is the answer. If there's no unique, I think all of them are of the same thing, all right? And then we check the next size. Now the next size, we need to, again, find if there is any unique. If we find uniques, right? If we find uniques, and then those uniques, now we have to compare to the bigger size. I need to make sure those uniques are not a subsequence of the bigger size. If they are not a subsequence of a bigger size, then boom, we have it. Which means if we have a situation like this, right? This one will give us a no-go. But if we do this, then the answer is 4, because this is a unique and it is not a subsequence of them. So the answer is 4. So we have the idea. We do have to write LCS. If I remember it correctly, we can write it. So let's give it a shot. Okay. So here is our solution. So this doesn't feel medium to me, honestly. It's like I have to jump a couple of loops, right? So like a couple of loops for this. So to begin with, we will create a function called def LC longest common subsequence, right? So we have S1, S2, both are strings, and all we want to do is to find the length of the longest common subsequence. So we're going to return an int. How do we do this? We need it's a DP table, right? It's a DP table. It can be of different size. So I think n will equal to the max of len s1 and len s2, right? Then dp will equal to 0 times n. I think it's n plus 1. And then this, I think we'll only need 2 because we'll have 2 strings, right? So what we do is we're going to say for no matching, right? So here's what we do, right? We have, oh man, I have to refresh my memory on this. I don't remember. So, oh, wait, hold on. No, that's not true. That's not true. I think I got it wrong. That's M and N. M and N. A, B, C, D. Okay, B, F, G, right? So I'm going to compare if these are the same. Yep. That's not correct. So it's M and N. M and equals this. I don't know why I do it the other way. Right, so this is going to be n plus 1. That's true for the columns. And for this in range, m plus 1. Right? So these are the DP table. And then we can say everything is 0. That's no matching. So we're going to say for I in range, I'm going to go from range m, that's row. J in range n, that's column. So what do? We're going to say if S1, m refers to S1, so I minus 1, remember we have to do I minus 1 is equal to S2, j minus 1. If they are the same, then dpij will equals dp I minus 1, j minus 1. All right, so if they're the same, then it's the previous one, right, plus 1, the number of longest common subsequence, right? Else, if they're not the same, then dpij, right, well, equals to, because we want the longest, so it's the max of dp I j minus 1, which means we match the current I, right, with the previous j, right? The current I with the previous j when I do a diagonal match, right? So this will be this or dp I minus 1 j. So I think that is the case. Let me think one more time. So if they're not the same, right? They're not the same, then the maximum longest subsequence, the length at this point will be either this, right, or this. Yeah. So that's that, and we'll go through the entire thing. Right, we'll go through the entire thing. Actually, I don't think this is correct. I think we have to go, if we go like this, we have to go 1, n plus 1, and 1, n plus 1. So we're doing dpij, but we do the minus here. So after this, we're going to return. Oh, we're going to have a result, which is 0, right? And then blah, 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 and the rest equals max. Oh, no. No. We just return the last part. Return dpmn. And actually, we don't have to. This, I think it can do it with on space, right? On space. So we just need 1. We get the other one, right? Let's try that. Let's try that. Let's make it more challenging. So I think all we need is this n plus 1, right? We don't need this. And we go blah and blah, and for each row we're gonna say temp, right? Equals 0 times n minus n plus 1, and then we say if they're the same, right? Then temp j. Right, that's the previous one, right? So we're going to say temp j equals dp j minus 1. So dp is I minus 1, j minus 1 plus 1. Yeah. Else say temp j. Right, else temp j will be maximum temp, the current, j minus 1, and temp, no, not temp, is a dp j, right? So we do this, and once we're done, we fill out, right? We do this, and we will fill out the temp. And once we fill out the temp, what do? We replace dp equals temp. And then we go to the next one. We'll go to the next one. Once we're done, we're going to return temp n. So that is an on space. I want to test it just to make sure that we're on the right page. So we just return LCS. Let's say ABCD and A, E, B, F, F, D. Right, that actually returned 3. So these are just, we're not testing it right now. Let's copy and paste it in. I'm going to make sure that this thing works to begin with, which we're not sure. That's the first one. Second test case will be AA. This one gives us 1, right? This one is going to be STRS. And this is find this STRS. Oh, self dot. It's 3, right? It's 3 because it's A, B, and D. And it's 3. Yep. Okay, so I think this one's correct. What happened?
You took electives for no reason.
What do you mean you took electives?
Why is it fixing? I took my degree audit, and now it's a second bachelor's student. Before it didn't say that. It says that I only need 6 electives, which I've already met.
Yeah, you can drop class. This Friday. You can drop Friday.
Why you took like 3 or 4 extra electives I didn't need to?
It doesn't matter. Just drop this one. Don't worry about the thing that happened in the past. It's already gone. It's fine. You just drop the current one, and then your life will be good.
I won't be part-time student. I don't know how that works because in order to be enrolled in a degree program, I have to be part-time student.
Well, then just take the class.
Plus, I have to. If it's not part-time, I have to start paying along.
Then just take the class. And it helps you because you learn about the machine learning. That's good. But just take the class.
The class looks stupid.
Oh, then just drop the class. Pick something else. Pick something that you're interested in. They have animal care. You can take that. They have skin care. You can take. They can take any class because you're already fulfilled, right? All you need a class for is to maintain a part-time student status. You can take any class. You like math? You can take math class.
I'm not sure.
Right? It doesn't matter which class you take.
I'll do a drop-in without even just to confirm.
Yeah, just confirm.
I have to do part-time.
Yeah, exactly. See, no problem. Don't worry about it.
2 classes left in engineering design 1 and 2.
Yeah, that's it. That's all you need to do.
One class?
Yeah, if you take one class, you can do just like.
It's like a waste of time.
Well, it's not a waste of time if you take the effort to learn Go, to write an app in Go. It's not a waste of time if you want to learn React, learn how to build a web app. You have so much more things to do.
But as before,
no, don't think.
This semester.
Yeah, don't think about the past. It's fine. It's fine. The past, let bygone be bygone. It's fine. Things in the past we cannot change. Let's focus on the right now and focus on how to move forward. If you only need to take one class and they also allow you to do so, then I think this is the best opportunity for you to branch out your knowledge base. You can do a lot more.
I think the data mining, I just need that class for the data science certificate.
Well, then take that class, even if it sucks. Take that class, get your certificate. Boom, problem solved. But you still need to confirm.
For next semester.
Next semester. Right? And then if it confirmed, then you have so much time. I mean, there's so many things you can do. So many things out there you can do. I mean, even if you don't want, you can also take another class. They have competitive programming. I think that would be a very interesting class. All right, let's get back to this. So what we have? We have identified that we need to, we don't have to sort it. We just need to put them.
Today because today was the last day.
Yeah.
1:30 and inviting something.
Yeah, exactly. All right. So what do? We need to group the strings of the same size together. All right, let's group them of the same size together. How do we do that? We need a groups. Let's call that a dictionary. A default dict of list. All right, because we need to know if there is any uniques. How do we know if there's any uniques? Okay, hold on. What we need to know is the string of the same size, whether there are any uniques in this. So we need a counter, right? So we need a counter. Can we do that? Can we do what's it called? Collections, right? We need a default dict and we need a counter. I think we can. For me, default dict, but it's gonna be a counter. How do we handle like a counter plus? Yeah, it's fine. So what we're gonna do is for s in strs, right? So what we're gonna do is groups len s, right? That's gonna be a counter s plus equal 1. Right, so once we do this, let's print groups, just take a look if fine. So we have length 3, and length 3. We have 2 of these and 1 of this. Okay, so now we have the groups. Now what we're gonna do is for size in sorted groups, right? It's gonna give us size, and then what we need to do is to go through the counter, right? Go through the counter and see if there is any unique ones, right? Any unique ones. So how do we find that? I mean, we have very few, so we can just iterate through, right? We just iterate through. So this is the current size, right? And then we go through the current size. We also need to find previous size, right? I have to find the previous size. And I don't think this is the best. Can we do this in enumerate, right? If we do this, then we can say for again. So within, so we have groups size, right? So within this, we can say for s and count in this dot items. If, right, we can say if count is equal to 1, because if count is 2, this one we cannot use. If count is equal to 1, right, then we say if I is 0, that means we are at the very beginning. So that will return size immediately, right? That means we are at the largest size. Oh, sorted this reverse equals true. All right, that means we are at the largest size and we have a unique. So that's it. The largest size is unique, that is the answer. All right. Else, if I is not 0, which means that we go through all of them, like there's nothing, right? So the largest size we find out is we only have 1 value, right? So s and a count is not, then we just keep going, and then we're done. So we go to the next size. So the next size I is not 0, so we need to go with that one to find. So we have to, what we need to do is for again the previous, right? For j in range to I, to current I. So these are the previous. Oh, we do need to get sizes. Sorted sizes. Sorted sizes equals, yeah, we do need to refer back to it. So sorted sizes, and then this is sorted sizes, right? And then for this, we need to get every single size, look into the group, use LCS to see if the current one is, right? So there we go. So we're gonna say is LCS. That's gonna be false, right? So we go through every single j, and we're gonna go through every value inside. So it's gonna be 4. We don't need, for s, we already use s. So for, and we don't need s. We just need count. I mean, in this case, oh, we do need s. S is the, so pre-s. So pre-s, right? Pre-s in groups, sorted sizes, j, right? Let's get the every single one of this, right? So what we want to know is we're going to call self.lcs. S is the current one under consideration, right? And then pre-s. So we're going to compute these two to find if this is equal to the current size. I think the current size is related to s. Yeah, if this is equal to size, then is LCS equals true, and we're gonna break, right? Which means this s does not work. All right, let's call it current s. So make it more explicit. So it's current is the current string. We're gonna compare to all of the previous strings, and we need to make sure that the current string is not an LCS of all of the previous strings. So if any one of them is, which is LCS that equals the size, right? Equals that because this one's smaller, this one's bigger. So if it equals, that means we're a no-go. So it's true, and then we break, right? And when we break out this, then we have to see if is LCS, then break as well. Because if we already find one, we don't have to keep searching. It's only after this is false, then we keep going to the next one. And after everything is done, right? So we break the for loop. That means something is true. I mean, that's fine. We just come out. We have is LCS, right? It's LCS. So when we come out, we go through everything. We say if not is LCS, then return the current size, right? If it's not, so if it's not LCS, so the current S is not LCS of all of the previous one, and the current one is unique, then that is the size. If it is, then we have to keep going to the next one, right? To the next one, and we will exhaust the current count, then we go to the next size. If we go everything and we cannot find, then we return -1. Okay, so let's just give this a shot. Enumerate, I forgot n. Answer is 1. That is very interesting. Why would I come out? Oh, that's -1. Type it wrong. Okay, so let's give this a shot. I am not worried about the runtime because let's run this code. Because the runtime is fine. It's only 50. All right, pending, judging, accepted. Nice. So we did understand this question correctly. It's what's the word? Is it complex or complex? It's complex. It's a complex problem, but it's not complicated, right? So long once you understand the inner workings, it's not complicated. But I do want to see if it's possible to make it simpler. Like this part. Maybe we can make it simpler. We can say for each j, we can put this one inside. How about put this one inside, right? We'll put this one inside, and then we go through all this. And if this, we're going to break. And I'll come out. And if it's true, and we break, and I'll go to the next one. And then for this, we just need to call else. All right? Oh, else. Do we call else? If we call else, that means we break. Yeah, else, we're gonna continue. Right? This one will continue. Which means if we break this, which means we have LCS, then we have to continue. And if we don't, you know what? I don't like it. Not as explicit as this. This is very straightforward. This is a flag, and then we check, change the flag will break, change the flag will break. If it's not, yeah, I like this. So I think this is a complex problem, but not necessarily complicated. So first, we realize that if that a longer string is always an uncommon subsequence of a shorter string. Therefore, it is the best strategy. It is the best strategy to examine long strings, right? Long strings first. Second, we realize that for strings of the same length, right, they, if there exists a unique string, then that string is the uncommon subsequence of all the other strings of the same length. Third, we realize that to find, now we already said if it's a unique string, therefore, our task is to find the longest unique strings, right, that are, therefore, we shall start with the longest strings. If there is a unique one among the longest strings, then we can return the length of that string immediately. Things get a bit more complex if there is no unique strings of the longest size. This means all the strings of the longest size are the same. In that case, we cannot use, we have to look for a string of a smaller size, of the next longest size. We do the same. First, check if there is any uniques. If there is not, we continue with the next longest size. If there are uniques, then the unique will be the uncommon subsequence of all the strings of the same size or smaller. But we must also check whether this string is not a common subsequence of all the strings of longer size. For this, we need to run LCS between the current string and all the strings of longer size. If the LCS returns a count, right, a size that is equal to the current string, that means the current string is a subsequence of a longer string, and that we cannot use it. Otherwise, the current string is a good one, and we can return its size. All right, let's talk about the runtime. So, let's say the length is n, and the size of this is n, and the length of string is n, right? So this part is O n m, right? It's O n m. So we have O m n, so the first one, and then this is what is this? This is hard to say because it's but it's smaller than O m n, right? Because it's O most is going to be n log. Oh, actually, yeah, this is going to be n log n, right? This is n log n because the worst case for this is each string is of different size. Then we go through this of sorted size, which is n, and then within that, right? Within that, we go through every single one, and then for every single one we have. Oh my God! Look at all the for loops. All right, I gave up. I gave up on finding its complexity. This is on. And this, I mean, we're basically saying we will check every single word. All right, that's basically what it is. Right? Not every single word, every unique word. Right? Every unique word. And then we have to compare with the previous. All right, I'm not going to do this. We'll see how other people figure out the time complexity. It's complicated. Anyway, I'm going to call it O1. We can call it O1. So we pass this with 60 milliseconds or a 15% ranking. So this is not the best solution. All right, not the best solution. Look at this. The majority is here, which definitely I think will be easier than how I do it. But anyway, let's take a look. Solution. Nope, no solution. It's fine. Yeah, this is like a hard medium, right? This is a hard medium. Is it 552, right? Is it 552 or 550? 520, 522. Why all the downvotes? I think that's a good question. Unless there's some trick that I didn't. Hash table, 2 pointers, string sorting. Huh. Okay, let's see. N2K solution. Okay. Is subsequence. So we can directly find all substrings for all words. 2 to the k times k times n. And the longest one, which is unique. Longest will always be one of our words, because if it is not, if I add some letter to it, it also will be uncommon. So what we need to do is the short words given the length in decreasing order, then for every word in words, iterate over all the other words and check if given word is subsequence of some other word. You can check if one word is subsequence of another in linear time. Oh. Check each word and compare it with each other. Ah, but we have the similar idea, but he's using is subsequence. How do you do a subsequence? If S is a subsequence of T, right? So we say T would iterate T, and for character in S, for character in S, if C in T, hold on. We are check if S is in T, then for each one, it shall be in iterator. What is this magic? We turn T into an iterator.
You think it's worth it taking an extra class for certificate?
Yeah, it's worth it. It's definitely worth it. Alright, what's this use? Yeah, what is this? Contains. Now we cannot use this because we have to keep moving on. True. It consumes. Oh, wow. This is some magic. Evaluate true if X is a member of S and false otherwise. Set supporters. Container type is equivalent to X in Y is equivalent to any X is E or X equal E for E in Y. It's a substring. User defined, which define contains, returns true if Y contains returns true. And get item. Or I think this is the key, right? So the expression but that's not a container. But I guess it's okay. Do not define contains, but do define iter xy is true if some value z, for which the expression xz is true, is produced while iterating over y. If an exception is raised during the iteration, it is as if in raised that exception. Yeah. So it iterates for you. Yeah. So this is from the documentation. This means when we do t equals iter t and check c in t, Python iterates t for us, and since t is now an iterator, each the values checked are discarded. This is indeed a very, very smart use of the language. I should probably do this so people can see that as well. Membership test operation, right? But do not define iter. But do define iter, and so y is true or something, while iterating over y. Do this and check iterates t for us, and since t is not iterated, the values checked are discarded. Yep. Oh wow. So basically we turn the check. Yeah. You don't have to run this check. And all of these complicated work can be accomplished just by checking all the words. Huh. Yeah, we just go through every single, so I'm going through the ones in the previous, but we don't have to just pick each word from large to small, so we sorted it based on that, and we pick each word and then go with everybody else. That's it. We pick a word and go with everybody else to see if it's a subsequence. Any word that is not a subsequence of anything else is correct. Yep. All right, so this is a better solution. Which also, because it's simpler, so we can analyze, it's possible to analyze its complexity. Now, when the solution is too complex, it's hard to. So, yeah, we can just call it is subsequence. Yeah, it will be easier, subsequence. Subseq, right? And we'll make sure that check whether S1 is a subsequence of S2. Given S1, len S1 is smaller, equal to len S2. All right, and this is using the SMART method. So what do we do? Let's now look at it. Let's try to do it ourselves. So basically, we need to iter s2 equals iter s, right? And then we just say return, or, right, we say for character in s1, when we check s1 is in iter s2, return all. This is a similar idea as mine, as solution 1, but to reduce all the clutter, we can simply test each a long string to test whether a long string is a subsequence of all other strings. Any long string that satisfies this requirement is the solution. In other words, we brute force it without having to find uniques or check find uniques and stuff, right? We can do this because the total size of STRs and the size of each STR is very small. Courtesy, the most impressive is how the Babchev examines whether one string is a subsequence of another string. I mean, that's like O(n) squared, but my solution is O(n) squared as well. This is much better. It's a subsequence of another string. I use LCS for this. He uses iterator and char and the in expression with iterator. Refer to my comment about how this works. So I have my comment, which I think I can copy and paste the link. Yep. It's really, really good. All right, courtesy of this brilliant solution. All right. Okay, so what do? We first sort. So we say STRs, sorted STRs equals sorted STRs. All right, key equals lambda s line s. We can just go minus line s. We don't even have to use reverse. All right, so we sort it, and then we just go every single one for s in sorted strs, and then we just need to check this with everybody else. Have to be all. So we're gonna say if all this all true is not a subsequence of everybody else, then we return len s. Right? Otherwise, return -1. So how about this? This has to be we have to use this. We have to enumerate this thing, and then for j, s in enumerate sorted strs, right? Oh, we can be smarter. We can be smarter. We can be smarter. Because we only need to check the ones with the same side. We don't have to check the ones. So from the start, right? From the start. Let's write this for j. Right? For j s underscore in enumerate sorted strs. If len s this is smaller than len s, then we break. I don't have to check anymore, right? So only check the ones, the side that's equal or bigger than this. If j equals to I, continue, right? And the last one is the break. So we're gonna have a flag. We call the flag valid right? Valid is true. So anytime we find one, then we can turn it into false, right? So if it is this, then we break. We don't do any more. If it is equal, we don't check it. We keep continue. And then we say if self dot is subsequence, current one, s, and s this, right? If this is true, right? If it's true, then we just say valid is false, right? Then we can say if it's true, but it would break here as well. No, we can say valid equals false, then break, right? Otherwise, if it's false, then we keep going, and then we jump out. Then we say if valid, then return. If not valid, we keep going. Okay, so that's version 2. S is not defined. It's 2. Hold on, that's not correct. If is subsequence. Huh. How? How is this one alright? So, it should be S. No, that's fine. If this is smaller than current, then we don't do anymore. Break. If it is the same, then I continue. And if S is a subsequence of this, then valid equals to false. Right? And then we break it. Valid. Hold a sec. Let's see. The subsequent S1 in S2, right? So every one in S1 has to be in S2. All of them will be true. No, it didn't enter. Hold on. It's weird. S and S underscore. Yeah, so its subsequence is wrong. For C in this. Oh, it's C in. Alright. My bug. Yep, then we pass. So basically, we just iterate through every single one, right? We don't really care if there's any repeats. If this would break, right? If this would continue, and if this we set it to false and then continue. Yeah, that's how I would do it, which I think is more explicit. Explicit is better than implicit, as always. All right, let's do the submission. Let's see how this one fare. Submit. Pending. Judging 51. It's a bit faster. All right, that'll be it for today. That'll be it. I mean, the only thing we can say is we're slightly faster because we have this extra check. So basically, everything we go this, right? And we go this, and we go this. So that's just square, right? O(n) squared, O(n) squared, and O(n) squared k, O(n) squared k, exactly. All right, that'll be it. I'll see you guys tomorrow. Adios.